So in our last class, we were doing problems like this where we were using synthetic division. You remember that, Dale? To try and write these in factored form. So, you know, if I had a function like this, and it's not in a nice factored form, and I was given a factor, I could do then synthetic division, and I'll review that process today. But then I wanted to write it in factored form. So we knew what the roots were, and, you know, eventually we're going to graph, which is what we're going to do today. So we're going to expand on that idea of synthetic division today. So why don't you write down this one problem that we're going to do. So we are going to graph f of x is equal to x to the fourth minus 3x squared minus, minus 3x to the third, minus 11x squared plus 3x plus 10. Now, as I said, this one's going to be a doozy because we have to graph this, but it's a fourth degree polynomial. So I do know a couple things. I know that the end behavior, the ends should go in the same direction. I know it has a positive leading coefficient, so the right side goes up, which of course means the left side also goes up because they go in the same direction. But I have no idea what the factors are. Remember in our last class, we were given these factors, right? We were being nice. Somebody gave us those factors. Today, we are not given them. So here is a process we're going to use to find the possible rational roots. All right, so the possible rational roots. Here's how we find them. We take values of factors of the last term. So factors of 10. And in fact, I'm going to call them P because if you were to look this up in a book or something, they will use P typically. So our values of P are all the factors of 10, which are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. All right, again, those are numbers that are factors of 10, of the last term. Anybody have questions about where I got those? No, you sure? You guys are good so far? I usually have a question or two by now on this. All right, so I got all these factors by the last term. Then I'm going to do Q are all the factors of the first coefficient, which is nice because it's only one. And so our possible rational roots are the top ones divided by the bottom ones. Well, if you dig anything and divide it by 1, you just get those numbers. So our possible rational roots are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Yes, Richard. Q are the coefficients of the leading term. So Q in this case is 1. If this was like 2x to the fourth, then it'd be plus or minus 1, plus or minus 2. All right, now these things that we have here, those are actually just hints or clues as to, like yesterday when we were given this x plus 1 as a factor, we're just not given a nice number. We're given possible numbers, and we have to figure out which ones are factors. And we do that by using synthetic division. Remember, when you do synthetic division, if it's a factor, you'll get a remainder of 0. You'll get 0 on the end. So for example, and I'm totally just going to guess one of these numbers. So I'll try 2. And I'm going to do synthetic division using these leading terms, which are 1, -3, -11, 3, and 10. All right, so to do these, I'm going to bring down a 1 first. I multiply 2 times 1 is 2 and add down. And then we multiply 2 times -1 and add down. And 2 times -13 and add down. And I can already see I'm not going to get 0 on the end here. And since I did not get 0 on the end, that means 2 is not a magic number. It's not a root. So that stinks. We have to try another one from this list to try. Which one you want to try next? 5. All right. So if I try 5, and I'll write this down real quick. You know, synthetic division is supposed to be quick. So I'll bring down the 1. 5 times 1 is 5. Add down, multiply, add down, multiply, add down, multiply. Oh my gosh. That was a good guess. So that's good. We got a remainder of 0. But remember, it's a 4th degree polynomial. We can have up to 4 rational factors, rational roots, giving us 4 factors. So what might be another number that we could try in here? We tried 2, we tried 5. I mean, I would say let's try easy ones, right? I mean, out of this list, yeah, 1 I think would be try 1 or -1 even. So let's try 1. But when you do that, we don't have to try it with the original coefficients. We only try it with the leftover coefficients. So I'm going to try 1, but I'm using the 1, 2, -1, and -2. So I'm going to bring down the 1, multiply and add down, multiply and add down, multiply and add down. I know we got lucky again. That's good. We got a remainder of 0. So we're on a roll here. So what we've learned so far, because 1 worked, we know that x minus 1 is a factor. Because 5 worked, we know that x minus 5 is a factor. We also, with each step of this, because we're getting a remainder of 0, we went from a 4th degree polynomial to a 3rd degree. And then we got a remainder of 0, went from a 3rd degree to a 2nd degree, meaning this is x squared plus 3x plus 2. Yes, Ethan. These are giving us our x coordinates. Yeah. So this factors into x plus 2 times x plus 1. And so if you have stuck with that, we're done. We have factored this. we have four factors, x minus 5, x plus 1. I'm sorry, x minus 1 and x plus 2, x plus 1. Yes, Rishi? Yeah, let me write that down and give me just a moment. So in factored form, we have f of x is going to be x minus 5 times x minus 1 times x plus 2 times x plus 1. So the question was like, oh, wait a second, can we recap that? So let me recap. I wanted to factor this thing. It's a fourth degree. So I could have up to 4 factors, okay? So first I had to find my possible roots, which would give me my possible factors. I got my p values, which are factors of the last term or the constant. My q values are factors of the leading coefficient. And p over q, this is my list of possible rational roots. So then I had to guess and choose which of those I was going to try for synthetic division, hoping to get a remainder of 0. Because if I get a remainder of 0, that means that it is a factor or a root. So I tried 2 first of all, but I did not get a remainder of 0. So I know that 2 is not a root. Therefore, x minus 2 is not a factor. Then I tried 5, and I did get a remainder of 0. And since I got a remainder of 0, that means that x minus 5 is one of the factors. Not only is it one of the factors, I then know that that's factored out. So I now have this third degree polynomial left over. And again, trying my possible rational roots with those remaining coefficients. So I tried 1 with those coefficients and ended up getting a remainder of 0, which told me x minus 1 was also a factor. And then that actually left me with a quadratic, which I then factored into my last 2 factors. And so finally, f of x in factored form was this. Yes, Miles?
Could you have done it like instead of the first one being 5 and the second one being 1?
Yeah.
You would have done it 1 and then 5.
Great question. Yes, you could. So you could, if I would have done, instead of doing 5, if I would have done 1 here, I would have ended up with the exact same answer. And so the order in which you do it does not matter. You're still going to end up with the same factors. And so ultimately it did ask us to graph this, but the graphing shouldn't be so bad. We don't have to get too particular, but we know that we have a root at 5 because of this guy. We know we have a root at 1 because of this guy. We know we have a root at -2 and a root at -1 because of all those factors. I also know that the right-hand side goes up because the leading coefficient is positive. And I know that both ends go in the same direction. It doesn't bounce anywhere because there's no squared terms. And so my graph would look something like that. Yes?
Will we ever have
Oh, good question. Would you ever have anything to the second power which would make it bounce? Yes, we'll do one of those in our next class, but the only difference would be like, remember when we did 5 and we got x minus 5? If we got down here, one of those factors might be x minus 5 again, in which case you just get x minus 5 squared, and that will cause a bounce in the graph. So you're getting it. Yes, we will see one like that soon. Any other questions? Yes. For the possible rational roots, you can have negatives. So for example, because I know that x plus 1 was a factor, if you would have tried -1 instead of +1, you would have gotten a remainder of 0. So you can have negatives. You know, I would try positives though first if you have the option, right? Because they're just a little bit easier to do the synthetic division. Anything else?